Francis. And Juby Valoran.
And I'm Joshua Vidor.
And we're the group that will discuss about the effects of dielectric in a capacitor. In most capacitor, a non-conducting materials is placed between the two metal pieces that make up the capacitor. There are reasons for this. First, a non-conducting material will prevent the two metal pieces from touching each other, which is important. Why? Because if the pieces of metal were touching, then there will be no charge stored at all. But here's a bonus of inserting a non-conducting materials between the plates of a capacitor, because it will always increase the capacitance. And as long as the area of separation between the plates of a capacitor will not change, then it will always increase the capacitance. Do you know what's the name of these non-conducting materials? It's a dielectric. Dielectrics. These are non-conducting substances which are insulating materials and are bad conductor of electric current. These are often called as insulators.
Why does the electric increase the capacitance? To find out, let's look this example. When you look up a battery of voltage V to a capacitor, charge will get separated. Now, let's say move the battery, the charge is stuck on the plates since the negative don't have a path in which to get back to positive. So even after we're moving the battery, the charge in the plate has gonna remain the same. The voltage will also remain the same as the voltage of battery that charge.
Now, imagine placing a dielectric between the plates of capacitor. The dielectric material is made of atom and molecules, and when placed in between the plates charge of capacitor, the negative charges on the dielectric are going to get attracted to the positive plate of capacitor. But those negative can travel to the positive plate since dielectric is a non-conducting material. However, the negatives can shift or lean towards the positive plate. This causes the charge in the atoms and molecules within the dielectric become polarized. To put in another way, the atom can stretches and one end becomes overall negative and the other end becomes overall positive. It is also possible that some molecules are just naturally polarized, like water.
Polarization. It is the displacement of charges when an electric field is applied. It makes up the one side of capacitor becomes negatively charged and the other becomes positively charged.
How does this polarization increase the capacitance? It's because it reduces the voltage between the capacitor plates. It reduces the voltage because even though there are charges on the capacitor plates, their contribution to the voltage across the plates is being partially cancelled. In other words, some of the positive charges are having their contribution to the voltage negated by the fact that there's negative charge right next to them. Similarly to the negative charge. So, the total charge in this capacitor will remain the same, but the voltage across the plates has been decreased because of the polarization of the dielectrics. Looking back to the definition of capacitance, the charge stays the same and the voltage decreases and the capacitance will gonna increase because dividing by a smaller number of voltage will result a larger value of capacitance. In this case, it will increase the capacitance by lowering the voltage. Dielectrics and capacitors serve three purposes.
First, to keep the conductive plates from coming in contact, allowing for smaller plate separation and therefore higher capacitances.
Second, to increase the effective capacitance by reducing the electric field strength, which means the same charge at a lower voltage. And
Third, to reduce the possibility of shorting out by sparkling, more formally known as dielectric breakdown, during operation at high voltage.